Let's look at some of the key results when it comes to your simple harmonic spring system, or the spring and the mass and everything over here. So say this is a smooth surface. I have not mentioned it till now, but all of this is smooth surface. Okay, so basically I pushed it to the left. So this is the force I have applied. And then I leave it. So this is the maximum displacement the spring has with that force. And this is the mean position. Okay, so this is the mean position. And here I have a displacement of minus, actually it's a negative. Now my question to you is, what is the kinetic energy at this point, at the maximum extreme scenario, and potential energy at this point? So our kinetic energy will be 0, and the potential energy, well, we'll not know the value as of now, we don't know it, but it will be maximum. What about the mean position? What will be the kinetic energy? When it comes to mean position, the kinetic energy, or kinetic energy when it comes to mean position, is maximum, while the potential energy is 0. Basically, if I let me show this video. If I happen to just let this go settle, settle in this manner, what happens? It will stay there. Means what? It has 0 potential energy, right? It has 0 potential energy. It's like keeping a object on a table. If you keep an object on the table, what is the potential energy? 0. Is it not? Here it is like keeping the object at a particular height. Here the kinetic energy is 0, while the potential energy is maximum. So this is keeping an object at a height. And this is similar to object just before it hits the ground. Okay. So these are the cases. So before it hits the ground, the potential energy is 0, gravitational potential energy. Similar to that, your spring potential energy at the mean position is 0, while the kinetic energy will be maximum. Ideally, if this happens to be a smooth surface, right? If I happen to, this is the mean position. If I happen to compress it, and if I leave it, it'll go forward and come back. Go forward and come back. It will never stop. Go forward and come back. When it goes to the maximum point, it will have the highest potential energy. It will keep reducing. What will happen to it? The kinetic energy will gain it. So it will have the highest kinetic energy at the mean position, while the potential energy will be 0. And when it goes to the left extreme, the kinetic energy is 0, while the potential energy is highest. So this keeps happening. Now, here we are looking at the results. Okay, so let's start off with case at the extreme position, plus or minus x max. So my potential energy will be equal to half k x max square, while my kinetic energy will be 0. Okay, so simple case. Now we'll take case at the mean position. So you have mean position x is equal to 0. So you have your potential energy will be equal to 0. while your kinetic energy will be half mv max square, right? Now, case intermediate, somewhere in between, wherein we have both the potential energy and kinetic energy. Intermediate position. So in this case, we can talk about the total energy. So that is your mechanical energy will be equal to your kinetic energy plus potential energy. So kinetic energy will be half some velocity v square plus half kx square, where x is your distance from the origin. X is distance from your mean position. Okay, guys. So we know the mechanical energy as per law of conservation of energy. Your mechanical energy will remain the same, right? Where did we get this expression? From the very first expression. Here, the mechanical energy, which is sum of U plus kinetic energy, will be equal to half k x max square. And this has to be equal to half m v square plus half kx square. A bit of rearrangement and we get an expression for everywhere half will get cancelled, and we have v is equal to k is common, and we have x square minus x square divided by m. There's a square, but yeah, we need to take a root. So that's that. That's the general expression. Again, we are looking at important results per se. So this is the general expression for figuring out a velocity at a at any point, actually, not only extreme point, at any point. Now we'll take a case at mean position. The velocity at mean position will be equal to k by m. So x square will be 0, xm max square minus 0 square root. And so this is nothing but square root of km times of x max. Okay, guys. So that would be your velocity at mean position. So basically maximum velocity, right? So this is the maximum velocity any object will gain that is attached to a spring over here. So these are the key results that we'll be using on and off. So you need to figure out how to derive it yourself as well. Quite simple actually.